Okay, I see we are not well, just a few people on the call. That's not a problem. So we're just going to discuss uh, what version control is, what it is, and look at a few basic Git commands. Okay, let's proceed. So this is an overview of what we'll be discussing in this call. So you know, just talk about version control generally, talk briefly about Git, talk about something called changes and how they differ from tracking files, talk about some of the basic Git commands and actually use them, and then share some resources that I feel would be very useful for anyone trying to learn Git. Okay, so first, what's version control? Um, I don't know. I've not heard any other person speak other than you, Habib.
Yes, it's
So
kind of the
I don't know.
platform
Can you
only
just
gives
give it a
speaking privileges to the hosts. So they would be sending messages into the chat
oh
section or the Q&A section. Or if
oh
someone wants
okay
to actually
okay
speak, then I can.
let's
Okay,
do that then.
all right then.
Um, so I'm just going. Okay. All right. So can someone just tell me what version control is? What do you understand by version control on the chat? Anybody? Or did you even hear my question? What is version control? Oh, okay.
I think you can just proceed.
Looks like no one. Yeah. Okay. So version control systems are tools for managing changes to code over time. Anyone with some little experience coding would definitely know that code will change over time. Business requirements will definitely change, and changes to business requirements would influence changes to code. Now, when code changes, it can become very difficult to manage. For example, uh, if the requirement was as a result of an idea that the business wanted to test out now, um, and they feel it's wasn't uh, good enough, and they want to return to a previous version of the system. Now it's become a problem unless they had backed up that the code for that particular version somewhere. Um, who made a particular change to code? That information would be lost the moment any other person starts working on that code. So all those things are requirements, are benefits that version control systems bring. So you are able to keep track of all changes to your code by using version control systems. You are able to work, for example, on large teams. You might be required to be working on different, you might need to work on different features at the same time. Now, you are likely going to be working on those different features off the same base. Let's say we had a version 1.0 of our application. So, and say team A should uh, implement a feature A, and team B should implement a feature B. Now, they both most likely would work off version 1.0. Not that they would wait for team A to first develop feature A and then team B would pick up the code from there. No. For efficiency, they would work off the same base, and when their work is complete, they can merge back to a central branch. Okay, so one other good thing about version control systems is that good version control systems are actually flexible. So they don't impose a particular workflow on your development. So you are able to develop in any way. Your organization can build policies around development, and the version control system would handle it without any issues. Okay, so what's Git? I just gave a brief description of what version control systems are generally. So now, since we will be discussing Git today, I think we should take a look at what Git is. Okay, so I think the strongest point here is that Git is the most popular version control system. It was actually built by Linus Torvalds, the author of Linux, although it's an open source project that's wide enabled and that. Well, Git is actually a very large open source project that has several contributors. So, but it was originally built by Linus Torvalds. So, Git is a distributed version control system. What this means is that every instance of a repository can exist without the others, but it can also integrate with the others to share code. That's basically what it means as a distributed version control system. So there are version control systems that make use of a central repository that uh, is the only point where you can access, uh, where you can keep track of previous changes or, uh, you know, access the history. But Git is distributed in the sense that the whole repository is on everybody's machine, on their development machine. So, and can exist independently of the others. So if someone decides to, take that same repository somewhere else, it's as simple as just creating another remote and pushing them. So it creates a lot of flexibility. Basically, you can work in um it creates a lot of flexibility. So you are not required to always be online connected to a particular central repository to uh, share your to access the Git history, for example. So you are able to work offline with all the previous changes that that exist in the repository without having to connect to a central repository. Now, this has one other benefit, and that's the fact that the performance of your team would not be limited by the performance of a central server somewhere. Now, what this means is, since you don't need to uh, remain connected to a central repository to do anything other than share code, since you are not uh, required to do that, you can work with the entire history up to the point where uh, you have on your development machine without having to connect to a different to a central server. You would uh, relieve that central server of operations other than pulling changes or sharing your own changes. So it improves basically your productivity as a developer and reduces the chances that the central server is ever going to get overloaded. Okay, so Git is efficient, it's secure, and it's very flexible, and it's the de facto standard for version control systems today. So basically, almost everyone uses Git. When I say almost everyone, I'm saying more than 70% according to I don't know what, but I saw the reference on Atlassian. So and they also reference somewhere else. So I don't know. I don't remember where. Okay. So but more than 70% of people today, of developers today, use Git. Okay. So when I was preparing this presentation, some random thoughts occurred. So I just thought I should share. Um, so basically, learn the tools popularly used to solve problems. More people have made mistakes using those tools, and their experiences are valuable to your own productivity. So learn those tools that people have actually been using. You understand? There is a reason, there is a benefit to not trying to reinvent the wheel, but mastering existing tools that have matured over time. There is a point, when a tool is new, you see many people talking about the risks of using it for production work. Now, the reason is not many people have used it, not many people have been opportune to give feedback on it. So as when for tools that have become mature, many people have used it, they've given feedback, the tools have been improved, and many problems have been resolved, and it's been shaped to solve people's problems better. So that's one benefit of using tools that are popularly used to solve problems. So you should learn those tools. It doesn't mean you can't, for your own learning, or when no such tool exists for the problem you are trying to solve, build what you need or use a new tool. But when uh, there is a popular tool that is already being used to solve a problem, learn it. It's actually very good. Well, why just think? The- Okay, so before we proceed to Git actions, I mean Git commands, basic Git commands. Let's just talk about changes and files. So version control systems track changes to code and not just files. So a change is a creation, deletion, or modification of a file. Git tracks actual changes and not just files. Now, so to explain this, I decided to just write this sample workflow. So for example, if you create a file hello.txt with 2 lines of code and add it to Git, then add an extra line of code to the same file and add it to Git. Git will detect that change. Now, that file is already in Git. So if Git was tracking just files, then the file is already in Git and there is nothing to do. So, but Git tracks not just files but changes. So Git will detect that change, that particular change, that line that you added. Git will detect that change, and you can also add that change to Git and share it with others. Okay, so let's just move on to this point. So basic Git commands. So you see these Git commands 1, 2, 3, 4, 5, 6, 7, 8. These 8 are what I consider to be the most basic of Git commands that are required for you to do uh any for you to be able to use Git at all productivity productively. I think you'd need at the minimum these 8. There are definitely others, and that's why I have actually shared resources. So let's walk through them. Okay, sorry. All right. So I'm just going to make a folder here. Call it DSC Git Off. Okay. So okay. So I'm just going to Git init here. Now, what Git init does is that it creates a new repository. That's just it. Basically, create a new repository. So when you initialize an empty folder as a Git repository, not necessarily, it doesn't have to be empty, by the way. So, but because we're starting from scratch here, I just want to use an empty folder. Okay. So when you initialize an empty folder as a Git repository, it starts tracking that folder and all subfolders of it. No, they become available for it to track. It doesn't start tracking them, but they become available for it to track. So all folders in that directory that is initialized as a Git repository, and all subfolders of that directory and their own subfolders, possibly like that, are available for Git that in that repository to track. Basically, that folder has become a Git repository. That's what it means. So now let's do it. Now a dot git. So let's see ls. So you can see the only two things here. I mean this and this. This refers to the current directory and this refers to the parent. So you can see there is nothing in this folder. I just created it now. So so now let's git init and you're going to see. So it's initialized an empty Git repository. So now if we ls a again, you can see a .git folder has been generated. So this .git folder would exist in the root of our repository. So and it contains Git information, including our actual changes and stuff. Okay. So so let's create a new file. Touch hello.txt. Okay. So I'm just going to add 2 lines of code to this. Not actually code. 989. Okay. So I just have this. Um so the first command, okay, we've looked at git init. Now the second command we want to look at is git add. Okay, so git add basically okay, so git add basically makes git start tracking files. It stages changes. Now when you stage a change, okay, when you stage a change, git makes it available for the next commit. So let me put another file. I have hello.txt. Let's have myself.txt. say who are you? I am star 99. I hope you understand the reason why I'm just choosing some random content. I don't use code. So I don't even have to think about anything. Good. Okay, so ls. Now you can see we have the hello.txt, myself.txt. So let's get status. Okay, so now we can add just one of this by doing git add hello.txt. And we'll check git status. Now you can see git look at this. The information returned by git status tells us that we are on a branch called master. We'll get to branches that we don't have any commits yet. We don't have any commits really. And we have untracked files. So so Git knows that these files are in the directory, the folder that is our repository. But Git doesn't know whether we want these files to be in the repository or not. So it's not tracking them yet. So but when we do git add, we've added it to the repository and we've staged it for commit. So that when we are committing, that change should be saved in the repository. So now I do git status. So now you can see the information has changed. I added just hello.txt here. Is anyone following? I've not actually got any odd feedback. Like Habib. Uh-oh. Habib. Okay, cool. You know, it was scary. If no, I was following and I was just talking. Okay. So you can see the information here has actually changed. Now we are still on the master branch. We've not changed that. We've not left that branch. Okay. No commits yet. We've not committed anything. But then you can see a new section is added here. Changes to be committed. So we've staged changes. So you can see this. It says what? We can unstage it by using this command. Git rm catch file. So this file, this flag here basically is saying that we should unstage it, not remove, not untrack it, just unstage it. Okay. So and we still have this that has not been added. So let's commit this one, this change. Okay. So I've added it. Git commit. Okay. So git commit with this flag hyphen m is saying that it is just short from message. So we want to specify a commit message. So every commit requires a commit message. So when you're specifying a commit message, always make sure it describes what you are committing, what changes you are committing. Now, one thing you can see is your changes are still tracked in the files that they are, right? So that's why it usually seems to people that Git tracks files, but the what Git is actually tracking are the changes. It just manages all those changes collectively as the files. So when you're adding the files. So when you do Git add a file, it will add all the changes to that file. Okay. So I thought that would be necessary to clarify. So git commit hyphen m uh created hello.txt. Okay, so you can see this commit message described what we did in that particular in that uh commit. The commit was it added only one file, hello.txt, which you can see here. Create mode hello.txt. Okay. So and we can see it's just one file that's been committed and two insertions. Two insertions because we have two lines that have changed. Well, two lines that have been added. So so if we do git status, now we can see this. Uh, this is still being on track, is not being tracked yet, and we are on branch master. Now, you can see it's not saying no commits yet because we have added a commit now. So it is no longer saying no commits yet. We already have a commit. Okay. There is not this change myself.txt has not been tracked. It's not been tracked by Git yet, and it's not being staged for commit. So we can add myself.txt. But let's do git add dot. Now when we do git add dot, we are adding the current directory to git. Now git add is a recursive action. If you add a directory to git, it will also add all subdirectories, all changes in all files in all subdirectories of that directory you are passing. Since we are passing dots and we are in the root of our repository, it will add all changes in all files in all subdirectories of our repository repository. Yeah, that basically means it will add everything in our repository. Okay, so the git add dot. So now you see we did not specify myself.txt here, but since it is in our repository, it will get added. Git status, you can see it's been staged. Okay, so let's git push. No, we've not commented it. Oh, sorry. So we've added it. Now we need to comment it. Okay, so git commit. Let's see. Created myself. Now you see when okay. Now let me illustrate that. Nano myself.txt. Okay. Now when I do git status, now it's you can see it's no longer saying that myself is not being tracked. It's been tracked, but it has been modified. So you can see it says okay, this file is has been modified. Now I can add the changes with the same git add command. Git add. Now I've added it, and then it's been staged for comments. So if I git commit, now look at the name I am message I'm adding for this commit now. Changed name from uh star 99 so Ahmad. Now git okay, so it's been committed. Okay, so so we have git init, git add, git commit. Okay, and now basically our local repository is already working. Do you understand? Now the next thing we want to do is add a remote. So let's do that very quickly. Um, let me open GitHub. So uh GitHub is a site that makes it, I mean, that gives you free repositories. Like you can have free repositories on GitHub. I'm just going to create a new repository. So I'll call it Git of none. Okay, public. I'm not adding anything. I already have that repository locally. So all I need here is a remote repository. So okay, so let me just copy this. There is going to ask me to log in and do all this, but I'm not doing that before on this PC. So git remote add. So now our next command was git remote. So that's so git remote just allows you to connect with other instances of the same repository. Basically, that repository, that remote doesn't yet have anything. So what we want to do is push this repository there, then we can interact with the remote repositories. You understand? So it is still this repository getting there, and it's just another instance that can have changes that I don't have on my own side. So I can pull those changes, or if I have changes on my side that are not there, I origin. Okay, origin is kind of like the conventional name to use for your default remote. So usually you have many companies and well anyhow many when you're working usually you uh, you'll have just one remote usually, but many times you probably also have multiple. So but for the main remote you usually name its origin unless you have different uh, different policies in your company. So so now git remote add this. Now, git remote add, you can specify options, then the name, then the URL for the remote. Okay. So here we use git remote add origin. So origin is the name, and then the URL is the URL you have just put. So you can see our git remote with git remote v hyphen v. So you can when we do this, you can see the remotes we've added. We can actually add other remotes as well. So and create a kind of web of repositories. But we're going to be working on just one remote for this session. So let's continue with this. Now I've added this remote, but I've not pushed anything to it. So let me look at it on Git. Okay, so you see this repository is empty, right? Uh-huh. Oh, now Git is you see this main. I think we should use main. Okay. Now we are on master. Yeah, normally by default uh the default branch, like the central branch, is kind of is master. You understand? So, but as a result of some make trying to make these things more inclusive, when you use this master slave terminology, it kind of creates some sort of whatever I don't know. So just to make it more inclusive is why they have decided to use these words main and several others like that in place of master and others that used to be more controversial. Okay, so let's do this. Let's set the branch. Let's change the main branch to main. Git branch m main git status. So now we are on main branch. Mhm. Oh, we get that. I don't have to look at the history, but I think I missed it. Okay, so now let's just git push. Now this U flag sets it sets the upstream branch. So basically, this our branch main here is our main locally. Now we want to connect it with this remote branch in such a manner that a simple git pull is going to pull from this branch, and a simple git push will push from this branch. And we will push to this branch, this main on origin. That's what this means. Origin main, like remote, then the branch name. So when we use hyphen u, we are saying set upstream. So we say git push -u origin main. So git push the contents of this branch currently and set the branch you are pushing to the as the upstream branch for this branch, and that branch is main in origin, which is our remote. Okay, hope that's clear. So my username, don't remember my password. I don't. I think this one going to. Okay. Uh, really, not nice. This thing should just be able to let me just copy password, not the password.
You are sharing your screen, so perhaps you can stop sharing and then copy and
Stop sharing. Yeah. Okay. I think I'm just going to do that. Okay. Okay. I think I can. Okay. Cool. So now, um, oh sorry, let me take this so it doesn't get distracted. Let me move this guy. Uh-huh. Then go back to this guy. Okay. So so now we've this was just me looking at. So when we do git push, it does all these operations. You can take a what it does. Okay. So it basically gets the changes off to that main branch on origin. So after that, because of the Jew flag we set, you can see this one. Branch main on our local set up to track remote branch main from origin. So the remote is origin, the remote branch we are tracking with this our main branch is main, and uh, the branch name is main. So now our main branch is main, no longer master. So we can work on main branch on uh, on Git. So it's not actually a requirement to use main on GitHub. It's not a requirement. So, but it is something that I consider good since it's all part of the move um to improve uh inclusiveness of the uh industry. Okay, so Git status. Now we are up to date with main. So we've done git push. Now let me go to GitHub. So I'm just going to reload this page. Then I'm going to okay. So I've reloaded this page. Now let me modify hello here so that you get something. It's 1099. Uh-oh. What is yours? Okay. So basically, okay. Alhamdulillah. Okay. So my name is 1099. What's yours? I've just added something to this. So now Now let's git fetch. So git fetch would bring those changes that we made there, but it's not put it in our branch. So it has put them in origin main that we have here. So if we do git status, now we can see that we are behind origin main by one commit. So we need to like pull those changes from origin main into our local branch. So let's do that. Git pull. Let's just do git pull. Since we have set it as the upstream branch, you don't need to set specify origin main explicitly. Just git pull will pull our changes. Okay. So you can see now if I nano or just cat hello.txt, you can see that change has been added here. So this could have been someone else on another PC, you know, writing some code. So and to bring that code in, it's as simple as just pulling. I just git pull. The git fetch is not necessary to bring the code. You can just do git pull and all the updates will come in. The git fetch is just to show you that I mean so that this git status message will be updated. So you can see that our branch is behind main by one commit. The commit we used to add that what's yours. So and you can see a file change one insertion. So you see what it does is that it doesn't take that file and replace your file. You understand? But what it tracks are the actual changes. So it is just that change to the file that it will put in your own file. So now we'll get to that point. But there are sometimes when some of those changes could conflict. We'll get to how to resolve them. Okay. So um we've done git remove, git push here. Great. So we have just git branch and git match to discuss before we round up. Mm-hmm. So git um, just okay. So our branch is up to date. Now let me get branch. Let me get branch. Let's just say feature A. We are working on a feature A. Um. So if we do git branch, we can see we have these two branches, main and feature A, and they both have the same commit. And when we do git branch, we are creating a branch that is pointing to the same commit that this our own branch is pointing to. You understand? When you just do git branch a branch name, we are creating a new branch that is pointing to the same commit that this our own branch is pointing to. So what a branch is in Git is simply a pointer to a commit on the Git tree. So understanding Git is something I would recommend you use the official documentation for. You understand the underlying principles of how Git works. You see, all what we've done just shows you how to use Git. You understand? But sometimes you need to do more advanced things than this. So it's recommended that you go to the official Git site and uh, study from there as well. Okay, so I won't dwell too much on all those details. Okay, so but just see a branch as a separate space that you can actually make changes without affecting other branches. I think that's a good way to put it. Okay, so git status. Okay, so now we are still on main branch as you can see. So we want to go to this branch we just created, feature A. So we'll do git checkout feature A. Okay, so git checkout feature A. Now we are on feature A. If I do git status, now feature A does not have a remote. So before I do anything, I think there's no change. So this time probably say something like there is no change. Feature Um, mm, oh, sorry. Like this. Okay, okay. There was no. Oh, so we have pushed feature A, and then we are tracking feature A and origin. So we do git status now. Status. So so we have on branch feature A. Your branch is up to date with origin slash feature A. So it is no longer on branch feature A. Nothing to commit. Working strictly. So now it knows that there is a remote branch that this branch is tracking. So now let's add something in that feature. This feature is simply to add a file, a.txt. So nano a.txt. That's what we're doing. Um, so let's see. So we are adding a.txt and we are also modifying one file, one line from one file. So you're going to see it. So git, okay, and this a.txt is just 28. That's one. Okay, so git add a.txt. So now our branch is up to date with our a.txt here. So clicking on this here, now you can see on the remote branch we only have hello and myself. But if we switch to a.txt and feature A, you can see we have another file here, a.txt, which we added 26 seconds ago, just now. Hello, myself. So that those are the files we have. Um, so let me just do something quickly. I don't know how many A's this is. So, but let's do something. Let me add some B's to it and put some spaces. Mhm. Okay. So added B's. So a.txt. Okay. So I want to illustrate the concept of margin changes before we round up. Okay, so we've done this. Well, let's pull this. This branch will get updated because it's. I mean, the change, the commit that this commit here was made on is the commit that this one. I mean, is the last commit of this branch. You know, when we do git branch, you can see the last commit that this branch is on feature A is added a.txt. Okay, so let's modify a.txt again. Nano a.txt. Okay, so here now, let me put C and D and E's. Okay, okay. So git add a.txt, git commit added CDEs to a.txt. Now, if we do something like git push, it shouldn't work. Uh-huh. Why? The reason is because there are changes on the remote that we don't have locally. So someone has pushed to this repository, to this branch on this repository, which was us. We did it directly on GitHub. So now let's first pull in that change. If I do something like git pull, I'm still going to have a problem. Okay, so there is a merge conflict. Now come and see this. Yeah, from this point. So it gets here, it sees that a.txt has been modified on our local in a commit and has been modified on our remote. And the base commit of both of them was, the commit that was before this one was the one that added uh was the one that added a.txt. the one before this one was also the one that added a.txt. So from that same commit, two changes have been made to the same file. You understand? From that same commit. So it is unable to determine how to resolve it because there are changes that were made in parallel. So now we need to resolve those changes by ourselves. So Git has failed to automate a.txt. Now we need to do it by ourselves. So it says what? Match conflict in a.txt. Now let's see how the match conflict uh can be resolved. So basically a.txt has been modified. So you can see all of these references that have been added to it. So you can see the so this our head is our local, and this here is the commit from the remote, like the ID for the commit on the remote. Okay, so that is this commit that added this. This head here is our own last commit, the last commit that this branch is pointing to. Mhm. Okay, so now we can see this. So now let's say to resolve this, what we really need is to add these and is okay. Okay. So now let's say that's what will resolve it. Now when we do that, we can just remove all of this. Now take note, if it is the actual code, you are likely going to like say, oh, this method was added, so you keep this method from this place. This method too was added. You get all this kind of stuff. So, but in the end, what you are doing is just you're going to modify the code to bring in the necessary changes from both sides and remove all those head and all those greater than, less than signs. You understand? Okay. So once you've done that, now we can status git add a.txt resolved merge conflict in a.t. Okay. So now we can see is ahead of origin feature A by two commits. Now the commits that it's ahead of origin with are first the commit we made, and second the merge commit. When we this commit that we just added. You understand? Mm-hmm. So now we can do git push. Now we do git push. Let's just reload this page. You see that the file has changed. Okay, so it has changed to the new content. So and our match has been resolved. Now you see what we even did here manually. Hmm? With that we had to go there, modify the file and stuff. Now they are actual. If you use your IDE, let's say you're using JetBrains IDE or you're using VS Code or anyone that you like. Many of these IDEs actually have good support for Git. You understand? So they would help you to visually um, merge your commit. So it makes it a lot easier to use your IDE than to go inside the file and start looking at it. You understand? So it's actually a lot easier to use your IDE. So learn how to use your IDE to merge Gits. So now, but look at this. Okay. So now if you take a look at what we have here, we have what? Let's check out our main again. Okay. Now you can see that there is no more a.txt because we are on main. If we check out feature A and ls, you can see that we have a.txt. So the work we can go to main, do another b and feature b, what can be the txt, and b feature b will not affect feature A and will not affect me. But in the end, when the feature is done, like we are done with feature A now, I will just once let's check out main back. Okay, So all we want is for the change to get back to the main. So we'll do git merge. So we are in main, so we want to merge the branch feature A to main. So I was doing git merge feature A. That's going to merge changes from feature A into our main branch. So git merge feature A. Now git branch. Okay. So now you can see main is on this same commit as what as feature A. So you can read more about this. Actually a very simple case of git merge, isn't that you just use fast forwards. Now sometimes you could also have add some other changes in uh in main branch, and it would have to use some other strategy. So so there are many ways that there are many strategies that you can use to merge when you use Git. So you can read more on that later as well. So but I think with this now, so and let's just Git push to me. So now as you saw before, this thing, I don't know if it should have pushed by now. Okay, that's pushed. So those changes, this a.txt was not in main before, but now it's there on the remote. So and our local repository is up to date with our remote repository. But as you can see, the local repository can be worked on independently of the remote. It is only when you need to share changes between them that you need to, push or pull. You understand? So they are complete repositories that are separate from each other. Okay, so I think we've actually covered what I planned to cover in this what I call it session. Uh-huh. So some resources that are I think are useful. I don't know. I think maybe I'll just share this slide so that you can, or maybe I don't know. I'll just I don't know. This keep I don't know. Well, sorry. Okay, so so we have the Atlassian Git tutorials at atlassian.com/git. We have the GitHub Git tutorials at this Git handle, and then we have the official documentation at gitsn.com. So these are resources I think would be very useful for everyone. Uh, if you are good with Git, there's probably still more to learn. If you are not good with Git, we also have very friendly tutorials at these tutorials here.
Yeah.
Right. So thank you very much for
Thanks a
having
lot.
me. It's been really nice talking
So
to you.
the session is being recorded. It's going to be available for others to also watch by the time we end the call. So yeah, I'm stopping the call now.
Okay.
Yeah.
All right. Thanks.